All right, good afternoon. Nice to meet you. I'm Vlad Frolov. Today I will conduct the meetup related to Ruby 3.4 on Rails 7. Yes, and today we will discuss the new features, the new possibilities of Ruby 3.4 and also Rails 8. But of course, we will revise all the features and updates since Ruby 3.0 and for Rails since Rails 7 until Rails 8. Some words about me. I'm software solution architect, Ruby fan and lover. I started the career as a raw developer, and I've been always using Ruby as a main instrument for the development. I do really like to attend conferences like Evruca and Wrocław RB. And yeah, this is my photo from the Evruca conference with the creator of Ruby, Mats. This was a really wonderful conference the last year. And today we will discuss with you the Ruby features and Rails features from 3.0, the new updates for Ruby and for Rails framework as well. And at the end, we will discuss some questions and things, if there any will be. Okay, so we do remember that Ruby 3 was introduced in 2020, and it had like several optimizations in terms of performance, like object separation, auto compaction, CPU performance, concurrency, like Falcon Ruby, Rec web server was introduced, async framework, static type checker, parallel computation, some like types checkers, I would say, static analysis, steep and sorbet, transition issues, as well, some transition parameters and backward compatibility also was introduced in Ruby 3. Yeah, the main goal for Ruby 3 was to increase the performance of the application in 3 times, as it was announced by mods, by other Ruby creators and contributors, that it should be like 3 times faster. In reality, it's appeared that it's not 3 times faster because we have still several limitations. We still have some performance issues, some limitations from Rails framework as well. So I would definitely say in reality, in production mode today, Ruby, if we use Ruby 3, it's not 3 times faster. And we will speak about it and we will discuss these limitations. Besides that, of course, there's some new features like Ractors and Fiber Scheduler. They were introduced in Ruby 3 as well. Static Analyzer, RBS, and TypeProf. Yeah, and as we discussed already in Ruby 3, it shouldn't be no more performance issues. Yeah, Ruby is really wonderful language to build any web application, startup, MVP, prototypes, enterprise applications. GitHub is built on Ruby on Rails, Shopify as well. Twitter at the beginning was also built on Ruby on Rails. And there was always one big problem in the performance for Ruby applications and for Rails applications. And people claim that the language should be faster, it has many problems, etc. And yeah, in Ruby, in 2020, Ruby 3 should be like 3 times faster. Yeah, first of all, after the Ruby 3 was introduced, there were some performance optimizations, especially for garbage compactor. Of course, when we say garbage collector in Ruby, we mean also the garbage compactor, because garbage collection in Ruby is also responsible for memory allocation and management, not only for just removing some useless objects or unused variables and etc. Yes, and in Ruby 3, this process was improved. If we speak about this in details, if I show you this schema, we can see that we have this well-known problem with memory allocation. And when we allocate some memory, there's some still free slots for memory. It's called fragmentation. It's a really well-known problem. And if we speak about Ruby and free, there were improvements for this process, especially for garbage compactor. After we run garbage compactor, after we apply garbage compactor, it reallocates these pieces of memory and solves the problem of memory fragmentation. So now we can see that after GP run, we have clear observation of memory, right? We know that, okay, 1, 2, and 3, they are taken. We store some objects there. 4, 5, 6 we can use for some new objects, larger objects. So this garbage compactor solves the problem with memory fragmentation. Besides that, the CPU optimization, of course, Ruby had the problem with CPU since it's interpreted language, right? And if we speak about Maths Ruby interpreter in comparison to JRuby or Truffle Ruby, Maths Ruby interpreter was the slowest, because Ruby, as you know, uses GIL, Global Interpreter Lookup, and GIL prevents Ruby to be the concurrent language, because we cannot run multiple processes on this the same processes on the same processor at the same time, right? Because I mean, for the Ruby program, because we have GIL and we cannot share the same data, the same objects across our processes, across our different Ruby processes. So that's why if we look at this benchmark, right? If we look at this benchmark here, we have some piece of code, right? It's executes this method many times. I would say we have test while, and while it's less than 4 million, right? 40 million. Then we increase it, and we just, at the end, we just measure how much time it took. And one important thing before going forward, we should mention the JIT, just-in-time compilator. Just-in-time compilation, it means the process when they interpreted pieces of code in Ruby language, if they called multiple times, for example, the same methods, they called several times, 100 times, 1000 times, and Ruby interprets them each time. We don't need anymore to do that. We can pre-compile them. JIT, just-in-time compilation, allows us to do that. And we can simply, the next time, when the same piece of method, the same piece of Ruby code will be called, we can just take the binary, already pre-compiled version of this method, and don't interpret it anymore. Yeah, here in this example, we wrote such piece of code. And if we speak about JIT, in Ruby free, there was mjit. So it's method just-in-time compilation. And if we look at this code, if we run this Ruby program using the JIT, to use JIT or mjit command, you should specify it in parameters. When you run Ruby script, you put Ruby mjit and the path to your script. Yes, plus we specified some parameters such as mjit verbose 1, mjit min calls 10, disable gems, etc. And when we measured this script, it's found we found out that if we use mjit, it's called 4 times, and after the 4th time, it started to be precompiled. As we can see here, we can see that 2 methods were compacted and they were moved to some special bundle. And this could help us, right? Especially if we have methods that are called really often and many times, they can be precompiled. But one important thing, to use MJIT in production, we could face with several issues, especially slowdowns. Because when we use just-in-time compilation, our program is executed. We also spend some time to compile it, to just analyze these pieces of code, right, that are called many times, compile them, move this to some special storage, and then when we again call this method, we should take from the special storage this implementation, like binary compiled compilation. So it also takes some time. So it's one of the disadvantage of MJIT. Besides that, we also use much memory, right? When we store and we precompile our methods, we spend some memory, right, to store this compiled method. So we store our methods like in memory, in random access memory. But besides that, besides this like interpreted methods, we also should store the precompiled version of this method. So it also spends some memory, and definitely, yes, it's the disadvantage of this. So MJIT is not really good to be used on production because of the several slowdowns and performance issues. Beside MJIT, in the next generation of Ruby, so in Ruby 3.1 and in Ruby 3.3, there were introduced two new YJIT and RJIT. If we say that RJIT was introduced just in Ruby 3.2 as a research JIT, so it's not ready for production. YJIT is the main JIT Ruby team is investing in by Shopify, right? So we can see that, yeah, there are some deprecations and things that YJIT has been developing in Ruby 3.1. It was improved. Then if we compare the YJIT with MJIT, YJIT is better than MJIT because YJIT is lazy, block-based JIT. It's written in Rust, right? It's maintained by Shopify. It's also a multi-platform, Linux and Mac OS. And now today, I would say that YJIT is kind of ready for production, because if we look at this in practice, YJIT is faster in most real Ruby applications in comparison to MJIT. And YJIT compiles block lazily. So it only compiles blocks that are run frequently, giving better return on investment. Yes, we are still seeing that, okay, in Ruby 3.2, YJIT also has some improvements, but nothing for MJIT. And Ruby 3.3 YJIT is much better. Now MJIT is deprecated. And finally, in Ruby 3.4, YJIT has better type propagation. It has escape analysis and memory usage optimizations that are really important for the usage on production. And MJIT is likely to be removed or deprecated. So now we have only YJIT and RJIT, but RJIT is still research only, not intended for end users. Okay, and if we look at this JIT's comparison, it looks like YJIT is really good solution. Why we cannot use it on production and always allow us to precompile methods that are called so often, so many times, thousands of times, hundreds of times. Why we cannot just use YJIT? Actually, this is really interesting question, because if we say that why we cannot do that, it's still difficult to use it because memory optimization is still required, right? Because we use much memory. So it's not really compatible with Puma yet. If we say like gem compatibility, so we should use some native extension or monkey punches for some gems. Yeah, the measures on development and on production are always different. So when we measure like, okay, YJIT on staging QET and see that, okay, it increases the performance, right? But on productions, the situation could be different. Actually, yes, YJIT also is disabled in CI, Docker, and entry point, and it's still difficult to say will it not cause any issues, especially with memory, because memory sensitive applications, especially in production, could could meet with this problem. That YJIT will increase in 2 times or in 3 times the memory of applications usage. So yes, to enable YJIT, right, we can simply say that, okay, Ruby YJIT bean rail server. We can say some instructions so that we will be using YJIT, and we can check in development console or put in Rails logs that YJIT is enabled or not. Also, we should use x86 Ruby builds. Yes, compile Ruby with enable YJIT, avoid Alpine Linux for Docker unless necessary because it's not compatible, and add YJIT to our server console test commands. Yes, and after that we should monitor, in our particular case, especially memory usage, request latency, CPU time, garbage collector frequency, and boot time, because we need to understand in some particular case it might help, especially if there's some like applications in which many methods called many times and for this short period. But to definitely say, are we going to use YJIT on production or not? We should just try it, right? And see how it affects the performance, right? Okay. Also in Ruby 3.0, there was introduced special type of worker, I would say. It's Ractor. It's like lightweighted worker that allows us to perform the program simultaneously, the same Ruby program. Simultaneously, I mean like concurrently. Actually, here's the example. We instantiate 2 Ractor and we calculate this power by Ractor. So we calculate 3 powered by 71 and 4 powered by 51. And we do it simultaneously, concurrently. These 2 calculations, they are performed in reality on multiple cores of our processor. I would say on 2 cores probably, right? Because we have 2 Ractors. Yes, and Ractors, they work around the GIL, and they offer us better parallelism. I would say today, if we look at this example, okay, we have some users, right? We have some Ractors. We initialize these Ractors. Then we try to search permissions for these users, we check the permissions for these users, we do it simultaneously, right? This is one of the business cases like that might be potentially used. But mostly for Rails applications, I would definitely say that Ractors are not still quite used, because in Rails applications, we have the application servers, right? We have Puma, we have Unicorn, and they can be scaled, right? They can be multiple threads, multiple processes. That's why Ractors are not really used for Rails on production unless we have some mathematical calculations or some processes related to some science or something like that to be calculated just really simultaneously. For regular business applications, we can use our default approach without Ractors. Yeah, actually here we can see that, okay, for these users, we had permissions, we had free users, we wrapped them in Ractors, we iterated through them, we called this permissions for, then at the end we collected these results of Ractors execution by method take, by calling method take, and we have all three of them. Yes. Here's also some like example of, yeah, Ractor. In some particular cases, in case if we have like calculate total sales for products, something like calculating for something, we might use Ractors in this case, because the calculations will be conducted concurrently. But beside this like kind of cases, it's difficult to say, besides the calculations, besides the science, where else we must or should use Ractors. Because in most cases, for regular things like our business logic, our users, etc., it's enough to use the basic approach without Ractors, without like multiple processes, multiple threads, because we use application servers. We can handle requests concurrently, we can handle some concurrent operations, so we can go with the default approach. Yeah, here are some like changes for Ractors. Ractors, they have been improved from Ruby 3.8 till 3.4. Now we have better performance. We have some like thread safety performance. We have some performance and improvements in terms of sharing the variables, because if we say what were the disadvantages of Ractors, it's like passing object between Ractors. We cannot like pass mutable object between Ractors, only immutable. Strict isolation also. Limited access to global state. No shared methods or procs, so we cannot like pass link to method or proc from one Ractor to another Ractor. Limited support for multi-threaded operations. Garbage collection issues. Yes, of course, because Ractors, they work across the GIL. No active record support as well. Yes, that's why using the Ractors is like a negotiable topic, because in some cases it might improve the performance, in some cases not, because, for example, when we create Ractor, we spend some time to initialize it, right? We spend some time to fork the process, because by default in Ruby 3, when we run the IRB, when we run the console, the main Ractor is started, and we can like fork the child Ractors from that. But still, we need to spend some time for that, right? Ractor also, they will consume more resources. We need to consider that as well. And in cases when we don't need to perform like some calculations, like mathematical calculations or prices calculations simultaneously for multiple like products, etc., I would not recommend to use Ractors. We can go with default approach. Then we have fiber scheduler that was introduced in Ruby 3.0 as well. Yes, it's like experimental feature. It was introduced to intercept the blocking operations as input-output operations, right? And it's like an interface. It's like a wrapper, right? Wrapper. So on the left image, we can see the example when we can use fibers, especially, yes, really connected with input-output operations. When we have multiple URLs, for example, 100 URLs, and we have to like simultaneously fetch the images or something like that, simultaneously open them, we can use fibers because in that case, we will not wait for input-output operations in that case. Once we make a request to fetch one image, at this time, we will not wait until the image is fetched, right? The fibers allow us to switch to another links and URLs, and they can be fetched at the same time. So we don't need to waste our time. We don't need to do it synchronously. The same example for email sending. When we need to send multiple emails, we can just simply like iterate with the users, call the fiber on them, and these emails will be sent. Also concurrently, yes, and simultaneously, because it's still input-output operation. Yeah, in Ruby 3.0 was also introduced RBS. It's like static analyzer. And actually, if we use RBS, we can write definition of Ruby classes, modules, methods, instance variables, variable types, and inheritance. And it supports commonly used patterns in Ruby code and advanced types like unions or duck typing. Here we can see the example of RBS. It like mostly looks like the regular Ruby code, but with some types like string, array, integer, etc., enumerator, post. And if we say about static typing analyzing, we should say about typeprof, because typeprof, it's an analyzing tool that allows us to convert our Ruby code from untyped code to be typed. So we could see on this screen that we have a user, right? We have a user, it has name, email, age. We can instantiate this user, and then we can call typeprof for this user. And it will simply execute this user creation instantiation and will generate the RBS file based on the types that we passed. I'm not a big fan of typing in Ruby, especially I knew some important phase from one guy. He mentioned that if you use types in Ruby, then something go wrong with your program and with your mindset, because Ruby is like developed to be dynamic. In some cases, for some like enterprise applications where we exactly should check for 100% that at this place we have string, not like number or something else, we may use RBS and typing, but I would say for just regular business applications, for regular applications related to startups or some like shops, etc., simple solutions like shops, some like storages, CMS platforms, etc. It's pretty enough to use the default Ruby without typing. Okay, here we see some changes across this typing, yes. From the Ruby 3.0 till the Ruby 3.4, there were some new methods, types that were introduced for this typing, for the static typing. Yes, such as untyped, no index, type, integer, string, array, hash, nil, proc, class, module, interface, type member, etc. They of course could be used in case if you use static typing for your Rails application. Then one interesting feature that was introduced also in Ruby 3, but yes, it was before in Ruby 2.7, but in Ruby 3 it wasn't improved. It's one-line pattern matching syntax change. So we can see here, for example, we have a user, right? It's like a hash, and it's has nested like fields name, age. We can use this like rocket operator, and we can just simply reallocate this data to variables on the right side. So we can just assign user name and age, and then we can use it. It's like JavaScript approach. The same for this array with numbers 1, and there is nested array with 2 and 3 and 4. We can just simply use this matching syntax and convert it to some data variables and use these variables easily. Then we can also use this with a case in, right? And here we can also check as arrays this comparison. And finally, we can use it like as a complex structure, like hashes, to check the status code and status name and do the appropriate actions based on that. Also, some more examples, especially with point example on the right, we have a point class, right? We can just simply create a new point, right? If this point inside this range, x and y, so we can just simply do what we need. The same example on the left side, right? We have name, age, we can extract them. We can also compare at the same line them with some numbers. All right. Also, we have more examples. We might use this also to extract some arrays or extract some codes. Okay, next it's deconstruct case method. For this deconstruct key method, we have two examples. We have a user, for example, right? User can be instantiated, and we can pass name and age to the user. And after we instantiated the user with some expected parameters, we might also check if user inside the expected name and age, and based on that, we might do some actions like put some name or age, etc. On the right side, we have example when we instantiate user with two parameters, Bob and 23, and after that we can just use this top level matching with this user, rocket name, and age, right? And now we can assign the user attributes from the left side to be the variables on the right side. And we can see that, okay, name and age, they are available right now. The same example for the user below. It's pretty the same. So we can check that, okay, if instantiated user inside this name and age, so equals them, we can do some appropriate actions. Okay, the same for deconstruct method. So for example, here we have point3d. We can specify the method deconstruct, right? Instantiate this point, and in case, right, we can check, okay, if it's this point inside this range that we specified. If it's yes, we can do some proper actions. Then we have endless method definitions in Ruby 3.0. So we can, as you can see, define full name in one line, weight, VAT, title, initialize, approve, everything. Of course, for one-line lovers, this approach will be really good, but I wouldn't recommend to do that because it affects the readability of your code. But we can, in some cases, I would say if method is pretty simple, maybe sometimes, yes, we can use some one-line methods like VAT on the line 115 here. Okay, then we have anonymous block arguments in Ruby 3.0. So if we have some block, we don't need to specify exactly the name of this variable. We can just use _1, right, as on the line 387, and just do everything we need. The same for more complex cases when we have an array of hashes. To access the key of hash, we can just simply iterate through the user and select this, the needed key. Then we have also one more interesting thing. It's hash literal value omission. So we don't need to write anymore if we use hash with the same keys as local variables. We don't need to repeat them. You can see on the line 154 that if we have user with age and with name, we don't need really to repeat them. So we can just omit them. The same for the below example. If we need to specify different like value for key of hash, we should write product name, right? But price we can leave because price will be the same as a name of this key. Time zone support in Ruby 3.0. We also have better time zone support because there were some problems before the Ruby 3.0 was introduced with time zones. Right now we can use them by default from this from the box, from the sandbox, right? We can use get local methods, we can convert time zones, we can move them, we can do some operations on them, etc. In Ruby 3.1, I/O buffer was introduced, and it allowed us to increase the performance of our application and optimize that, because especially in production, we do have really to do some operations on some large text files or PDFs, etc. To increase the performance, if we would like to work with low-level data, especially with chars, with bytes, etc., we should use I/O buffer, especially if we have, for example, PDF on production, right? And we build some mechanism to analyze this PDF and to check the content of this PDF, right? For this kind of operations, we should use I/O buffer because it will increase the performance. We could process our data in chunks. Yes, as you can see on the screen, we can input some large data and then read it in chunks and processes. Then we have a new feature that was introduced in Ruby 3.3. It's Prism parser. Now we can parse Ruby code easily. So, for example, we have a source here, we have method definition, and we have a result, right? Then we can put it to be parsed and check if it's code valid or not. So we can now check the validness of Ruby code. Why do we need that? Because in some production applications, in some business applications, we need to generate some code. We need to check some metaprogramming code that was generated. For example, in some applications that interact with user and where we can pass Ruby code as well, like learning applications, etc., we can pass real Ruby code and check if it works. So it will build this graph with tokens and check that, okay, all of them are correct or not. In case of success, this parse method will return us a success. We can check it as on the line 180 and do the proper actions. In case if there are some errors, for example, as on the line 186, we can also check for errors. And in case of error, we will print this message. Here's more complicated case, like we input some Ruby code, right? We parse this Ruby code with Prism. So we check if parsing was successful, then we iterate through the result. We iterate through this abstract syntax tree that was built, and we check for methods, childs, select them by type. We can select like children of children, etc. So it's like a tree of tokens and of codes that was parsed and built. Then we have immutable value objects. They appeared in Ruby 3.2. Actually, we have here the example with point. We define point, it's like a data, define x and y. And when we instantiate this point with x0, y0, we cannot anymore change it. So this point cannot be changed. We need this in case when we should operate by immutable objects like constants that shouldn't be changed inside our application across like some business processes. If we speak about like one more example, contact, we can define contact with email and phone, and this contact cannot be changed. So we can work with that, we can operate by that inside our application, but it cannot be changed anymore. Then we have default block parameter. Okay, we can iterate through our collections. It's like, it's pretty the same that we had here. Yes, as anonymous block arguments, pretty the same. This default block parameter, they were appeared in Ruby 3.4 that was just introduced recently, and there we can use like it. So we can iterate through 1, 2, 3, each puts it, do some operations, etc. The same for squares, like the same example, we can multiply it to it, and it will give us the expected result. Also, there are some changes related to language, especially in Ruby 3.4. We have method, for example, greet, right? It accepts some keyword arguments and puts some result based on the keyword arguments. Now Ruby allowed us to pass nil instead of keyword arguments. So in case if we pass nil, like as a hash with 2 asterisks, it will not raise the error. So as you can see, it will provide the output. This is the new change that was appeared just now in Ruby 3.4. And now we have a new happy able support. This is for WebSockets. Actually, we can establish a TCP connection with improved reliability. Sometimes we do need to do that. And for example, if we need to do some DNS resolution, etc., to improve and increase our connection speed, if we have some like operations with DNSs, with connections inside our like application, we can use eyeballs version 2. They like supported by default in Ruby 3.4. We can just use socket as we usually do that, use TCP or UDP socket. Yeah, and we can just simply resolve the things that we need, especially for DNS or for connections. Then we have improved regex performance in Ruby 3.2. There was also the great update. If we have like large calculations for regex matching right now, it has optimized mechanism for digit and large strings, and we can like use regex for big portions of data. The performance would be better since Ruby 3.2. Okay, next we should speak about Rails, Rails 7 and Rails 8. Now, in Rails 7, if we would like to revise this kind of things, JavaScript is no longer require Node.js or Webpack. So we don't need Webpack. That's really great. Yes, Rails 7 removes Webpacker, and instead of that, we have import map to manage JavaScript. This reduces the complexity of configuration of JavaScript and makes us easier just to use modern JavaScript frameworks. And import map allows us to pin JavaScript libraries directly in the browser without the need for bundling. Yes, it makes us these kind of things to be simpler and faster for many applications, especially for small to medium size apps. Or projects that are not required advanced JavaScript, because not all projects really require advanced JavaScript. Sometimes we can live with ERB files with server-side rendering. Who knows? Because sometimes we build some simple startups, simple projects, simple shops, etc. There might be no JavaScript at all, right? And why do we need to use Webpacker in this case? Yeah, we don't need in reality. And Rails 7 allows us to escape that. Then Tailwind CSS, it's default CSS framework in Rails 7. So we can forget about CSS, writing this CSS in Rails project, right? When we have like this like styles folder, and there we have like some SCSS or CSS, etc., or SAS, and we just define like these big portions of code, and now we can just forget about it. We can use Tailwind. We just need to initialize our applications with DS build CSS Tailwind, and we can just simply use it. We can directly write classes, Tailwind classes in our HTML files, and CSS will be applied automatically. Then one more interesting thing, Hotwire, Turbo, and Stimulus. Yes, Hotwire is a new framework introduced by Basecamp and included in Rails 7 to build fast and dynamic applications with minimal JavaScript. And it includes two main components, Turbo and Stimulus. And together they can help us to create modern and scalable application without need to writing custom JavaScript. So nowadays we have two modern approaches. SPA is single page application, so we have backend in Rails, Rails backend in API mode, and we have two like one or many single page applications that interact with our backend via API or via WebSockets, via different protocols. And the second approach, the modern approach, is Turbo and Stimulus, that was recently like introduced, and now it's like a real topic to select between, like, should we use SPAs or it's enough to use Turbo and Stimulus. Because if we speak about Turbo allows us to speed up our application, to build it and be updated. I mean, like, data to be refreshed on our pages dynamically without reloading the pages. So we can go with partial page updates. And instead of loading the entire page or reloading it, Turbo updates only the necessary parts. So we have three key features of Turbo. It's like Turbo Drive, Turbo Frames, and Turbo Streams. Let's go to the real example. So we have post controller, for example, in Rails application. It's regular business model. We have two actions, show, like, and set post, right? It's like a private method. As you can see here, nothing like is really unusual. We just load the post and show it. We have likes, control action. We can like post, and the number of likes is increased. Then we respond to Turbo Stream and format HTML redirect to post. Okay, that's pretty the same, but we have now one more interesting line here on the number 108, format Turbo Stream. And if we go here, for example, we could see that we have posts show view, right? Show HTML ERB. We have title, body. We have button to like the post. We have likes count of this on this post, and now we can see this one more interesting line: TurboStream from post ID, TurboStream append post. So actually here, this magic happens. So when we use TurboStream from, and when we actually receive the updates for the post, especially the number of likes are changed, they can be just updated on our page without any problem. They can be updated without reloading, without some complex operations. Only the number of likes will be updated. For that, we need to specify some special partial. This is called likes count, like TurboStream, and here we can only see the number of likes. So when user clicks like on the post, the number of likes are increased. User sends the put request, right? We can see here on the button patch method, data TurboStream. It's sent to server and comes to the controller. Controller increases the number of likes, then it TurboStreams again. And since here we have TurboStream from post, it will automatically update the number of likes count, because it has partial like TurboStream. It will only update this part with likes, nothing more. Yeah, for that we can simplify this usual routes, and it will work. But of course, we need to be careful with IDs, because when you operate by turbo and stimulus, you might have situations when something was updated on the page, reloaded, refreshed, but you didn't expect that, because it's probably because you specified the wrong ID, or you didn't specify the ID, or the ID is incorrect. Okay, so for stimulus, pretty the same thing. Yes, it's a modern JavaScript framework designed to work with HTML, but it provides better flexibility for us, right? We can control the code execution on the client side. For example, here we have pretty the same example. We have this show view for posts. We have this likes count as a partial, right? But now we have a controller, and this controller is written on JavaScript. And as you can see here, when user clicks button like, we allocate the data to the data controller like and action click. And here we can, in this controller, in stimulus, we can simply handle this action, right? We can fetch, we can call the method patch, we can make patch request to the backend, and after getting the response, we can change the count of likes for this post. Yeah, this is pretty the same what we had for Turbo in the previous example, but using stimulus gives us more flexibility. For example, in this case, we can just simply rewrite this logic to be more complex, or to handle more cases, or to do some more stuff on the user side, on the client, to update some, I don't know, styles, etc. This stimulus will allow us to do that. Okay, then we have models encryption in Rails 7. So now we, for example, if we have user, we have email, social security number, we can increase them. We can encrypt them. And to use this approach, we need to specify credentials, right? Active record encryption, primary key, secondary key, key, derivation salt, and we need to write the migration. And then Rails will automatically, when saving to the database and extracting it from the database, Rails will automatically encrypt and decrypt it easily. So, for example, if we would like to store some email or social number in database, it will be stored as encrypted. But when we load it from database, it will be decrypted automatically by Rails, and we can work with that easily. Then multiple database improvements. Yes, in Rails 7 we have significant improvements for high-loaded applications, I would say, because sometimes we need more than one database, especially for applications where we have like master-slave approach, or where we have many requests, and we have two databases, one for archiving or for storing, for reading, and the second one for writing, etc. So in that case, we can specify right now in config database YAML two databases as a config. Yeah. Then we have native rate limit support. Yes, it was introduced in Rails 7.1. So we should enable in our config environments production.rb file, we should enable config cache store and use Redis for cache storing, configure Redis. And then in controller, you can see we can just simply check rate limits. So in case if your infrastructure or your like DevOps team difficult to interact with them, or just in case when you would like to have flexible rate limits, because when if you configure rate limits, for example, on Nginx, right, you configure, for example, 3 requests per minute, it means that the 1 minute will be divided and you will be able to make 1 request per 20 seconds. But in case if you would like to have more flexible rate limits, for example, you would like to really have 3 records per minute, they can be at the beginning of minute all of these 3 requests, 3 or 5 requests, etc., as many as you want. You can configure your own rate limit strategy. So you can use before action callback, you can enable Redis, and you can use now request rate limiter limit. And you can use some special key, for example, header authorization, to use for rate limiting. For example, IP address or authorization header or some user-specific data, etc. Everything you want, you can use it, and it will be really flexible and scalable. Then we have solid cache, queue, and cable that was introduced in Rails 8. Now in Rails 8, we don't need really to use Redis. We don't need really to use Sidekick. We can use solid cache. It will provide us with caching, so with like temporary data storage with queuing mechanism, and for WebSockets as well. We can use solid cache for WebSockets, especially for the Rails. If for the Rails 8, if we speak about native background tasks, they were appeared here right now, and now we can use Redis to store them. We don't anymore need to use Sidekick. We can use background jobs from Sandbox from Rails 8 by default, and we can just configure Redis, and we can go off with Sidekick. We don't need Sidekick anymore. Yes. Here's a simple example with sending the email for a user. Rails 8 also introduced native API versioning, so we now can simply specify in our roads file versions for our APIs. Like we have namespace API, we can specify version 1, version 2. Yes, this approach allows us to maintain and evolve API without breaking existing clients and facilitating smoother transitions between API versions. Yes. Now we have Turbo Streams 2.0. They were introduced also in Rails 8. This is related to the example with Turbo and Hotwire that I showed you previously. Now they increased the performance and enabled more efficient real-time updates without extensive JavaScript. They made some significant changes and improvements in this area and optimize this turbo streams. Yes, this will allow us for dynamic updates for our UI, such as appending new messages to chat or adding new posts or some dynamic data updates without reloading the page. Now we have also view component integration. Yes. Especially view components are also used for a Hotwire approach, right? So we can write front-end components the same and treat them the same way as a Ruby code, right? We can just initialize some button component, like page component, user component, etc. The same principle which we have in React, pretty the same. And now Rails 8 integrates view component, yes, and it helps us to reuse these pieces of front end and test them, right? Test for these UI components. We can test them, right, with our spec and scale. Yes, TypeScript support by default, right? Now Rails 8 supports TypeScript. And yes, it enhances our development experience with type safety checked for JavaScript code. Yes, we can use TypeScript. We can have this static typing as we just discussed for our Ruby code. Now it's the same for JavaScript. We can use it for stimulus as well, right? We can just include this gem TypeScript Rails and use it easily and check our code on the client, the types for code. Now, yes, also in Rails 8, they were enhanced some security features. For example, default protection from forgery. Now we can prevent from CSFRF attacks, cross-site scripting attacks, to ensure the safer handling of sensitive information. Yes, that was it. Thank you so much for your attention. Yes, in case if you have any questions, please ask them in the chat. I will try to answer them. And please share your feedback. Feel free to leave your feedback and thoughts regarding this meetup. Yeah. Yeah, please ask your questions in the chat. Thank you. Yeah, especially guys, if we speak about Ruby on Rails, I will definitely say, based on all of these features that we just observed, that Ruby is ideal language and Rails ideal framework for building web applications, because we can still use dynamic typization, we can use static typization, right? We have many solutions right now when we can combine these approaches, right? If you like really strict to backend development, we can use stimulus with Hotwire, right? We can write front end on Ruby language. And this is really great because we can test these front end components, especially if we speak about Hotwire, right? If you would like to separate these approaches, right? If you would like to build only backend on Ruby, but you have like a dedicated team who will be developing on React or Vue.js or Angular, etc., we can use this approach with SPAs. We can use this single page applications approach, and our backend will, our front end applications will communicate with our backend, and we will have only like Ruby. If we build applications like startups or real simple applications, we don't really need JavaScript or, for example, some difficult UI UX logic. We can just use static server rendering with ARB files and use them. So yeah, with Ruby on Rails, we can combine and use multiple approaches. And now, especially after we started to have these new features, such as static type checkers, new rate limits approaches for Rails from the sandbox, encryption for models, we can easily build any applications for short time. It will be really fast, and we can use these tools. Yeah. Yeah. Hotwire is awesome for full stack. Yes. I wouldn't say that only for the full stack, right? If we speak about developers, right? In the context that you wrote, maybe you meant not developers, but if we speak about like Ruby developer, right? And Ruby developer never work, for example, with JavaScript. Ruby developer can easily write components and logic without JavaScript using Turbo, for example, Turbo streams. If we need to increase dynamically the number of likes on the page, etc., it can be really easily, and we don't need to reload the page. We can update the only parts of the application easily. Yeah. Yeah, the next question, is it efficient and what extent to use Rails native caching instead of Redis? Yes, actually, I would say from Rails 8, we just can't try to do that because actually the cache that they developed, right, the solid cache, they promise that it will not be slower than Redis in terms of performance, in terms of request handling, and in terms of time to connect. Actually, if we speak about Redis, yes, of course, Redis is a great solution for all of applications in Rails because, right, it's random access memory database. We can cache, we can use it for advisory logs, for storing some temporal data, right? But now to use Redis, right, we need to host it, right? We need to actually sometimes in some cases, for example, is on Heroku, we need to buy additionally it, right, to use Redis. We need to specify, set up this gem. We need to set up the connection with Redis, right? So we still have to do some things. Now, Rails 8, they suggest from the sandbox, so we can use it without any additional setups. And they promise that it will be kind of quick solution, not bad than Redis. Yeah. Actually, okay. So what do you like more, Hotwire or API only mode? Yeah, actually, I would really say that if we speak about these two approaches, they're pretty different. It depends on your project and on your client's needs, on your business goals, etc. Because sometimes, right, it's easier to say, okay, we have a team, right? We have 2 developers. They're pretty ready to work with front-end logic, the Angular developers or React developers, and we have 2 backend developers. We would like you to separate these obligations completely. Yeah, in that case, of course, since like comes from the client, in that case, yeah, of course, we will use the separation of approaches. We will have backend separate backend, we will have separate two SPA applications, right? But if, for example, if I will develop a startup for my purposes, now I would go with Hotwire approach with Turbo and Stimulus, because for me, as a for Ruby developer, it's more closer to work with Ruby, not with JavaScript, because of course Turbo and Hotwire still requires some JavaScript, right? But not so much, I would say. And for me, personally, I would go with Hotwire if I develop application for myself. But of course, if we speak about projects where we have like budgets, clients, and rates, etc., and some teams already set up, it's impossible just to come and say, okay, let's rewrite it to Hotwire. Yeah, let's go off with SPAs, etc. Okay, so yeah, for big projects, which one would you personally choose, Sidekick or Solid? Yeah, for now, since, to be really honest, I haven't used Solid yet, but I would like to invest more time and check the feedbacks from the community and how would it affect for real performance applications. I would say that for now, I will still use Sidekick because it's pretty, it's pretty fresh. Maybe in some time, of course, it will be fine to go with Solid. Yeah. Mm-hmm. Okay. Yeah, we have one more interesting question. Solid Q is running with SQLite only by default. It started next to Rails server. Okay. What if we have multiple Rails servers? Can we replace SQLite? That's a good question. Yes, because in Rails 8, SQLite, it's like, yes, they really push this database in Rails 8. I do remember that from the conferences. And the question if it's run, yes, by default, it started next to Rails server. What if we have two multiple Rails servers? Can we replace SQLite? Yeah, this question, it's I need to think about. If we have multiple Rails servers. Yeah, that in that case it might be a problem because Solid. Yeah, but I'm not sure. We can. Yeah, Solid is run by SQLite only. If we cannot, for example, configure the Solid, if it's strictly related to SQLite, right, tied and connected with SQLite, we cannot go off with that. We cannot reconfigure to say that, okay, Solid, let's use Redis or something else, and then yes, probably it might not work, this approach. Yeah, but it's a good question. I will probably think more about it. To if we have multiple Rails servers, can we replace SQLite? Yeah, how to do that? Actually, if Solid doesn't allow us to do that, but as I wrote, probably they might have something else. We can configure the storage. Yeah, if they allow, then we can do that. But if not, then we can't. Okay, thank you so much. Thank you for your attention. Please leave your feedbacks and have a good weekend, guys. Bye.